Hey, what's happening, everybody? All right, we're going to move on to probability in this lesson, and we're going to start with just some basic definitions of probability. There's two kinds of probability, well, really three kinds, but two kinds that we're going to focus on throughout this chapter. Your goal for this video is that you're going to learn to calculate theoretical and experimental probabilities. Those are the two kinds of probabilities that I was referring to. There's also subjective probability, but we won't have to worry about that overly much. All right. As I said, there are basic definitions that I need you to know. And one of those definitions for this video is what an event is. An event is simply an outcome from an experiment. All right. Now, I'll tell you what an experiment is here in a moment, but some examples of an outcome from an experiment. One of those would be that you flip a coin and a heads shows. Flipping a coin and showing a tails would be another outcome. Another example of an outcome would be that a red token is chosen from a bag with red, yellow, and blue tokens. All right? Or it could be that we look at the grades in a class and we look at the number of 5s that students received in a class or the number of 7s that students received in a class. Those could be outcomes as well. All right, so that's what outcomes are. Then we also need to know what an experiment is, and what an experiment is the process by which we obtain an outcome. Process by which we obtain an outcome. Now, we said an outcome could be flipping a heads on a coin or drawing a red token from a bag. Well, examples of experiments could be flipping a coin or rolling a die or finding a defect in a production cycle or determining or giving a test and grading it on a scale of 1 to 7. There are so many different experiments that you can run. And then each of these experiments produces certain outcomes. All right, so you've heard a couple of definitions. Hopefully those make a little bit of sense. Now for the different types of probabilities that we want to talk about in this chapter. Actually, there's one more definition I want you to learn. Then we'll get into the different types of probabilities that I want you to learn in this chapter. The next definition, and this is super key to any probability question, is sample space. And what a sample space is the set of all possible outcomes from an experiment. All right, the set of all possible outcomes from an experiment. So the sample space will depend on the experiment. For instance, a coin is flipped. Well, there's only two outcomes there. You can either get a heads or a tails. And so the sample space for that particular experiment would be that you get heads or tails. Now, we're going to refer to the sample space as being part of what's called the universal set. If you ever learned set notation, you'll know what a universal set is. And in this case, the universal set can include the outcomes heads or tails. All right? Or you could have a token that is drawn from a bag with 3 colors. And it could be that red, green, and blue are the only colors in the bag, and so the sample space includes red, green, and blue. You might roll a die that has the numbers 1 through 6, and the sample space is the number 1, 2, 3, 4, 5, 6. Or you could have the numbers 1 through 8. There are lots of different things, but a sample space is always a set of all possible outcomes. Okay, now, for the types of probability that we're learning. The first is theoretical probability. And this is the probability that you're most used to using. Now, I need to give you a formula that you use to find theoretical probabilities first. You see it on your screen, but I need to explain it to you. The probability of an outcome A occurring is calculated by this. You find the number of ways that that outcome can occur, and you divide it by the number of outcomes in the universal set, or in other words, by the number of outcomes in the sample space. Let me label some of these things. First, you need to know what this notation right here is. The P of A means the probability of outcome A. Now, that could be the probability of flipping a heads whenever you flip a coin. It could be the probability of scoring, in the 90th percentile for, an SAT, that kind of thing. Then the next thing you need to know is what this N of A means, and what it means is the number of ways that outcome A can occur. So if you happen to roll a coin with roll a die that has 20 sides, and I want to know what the probability of an even number is, well, 10 of those 20 numbers will be even, and so that would be the number of ways that that outcome could occur. All right, and then finally, the N of U represents the number of outcomes in your sample space. So again, going back to that 20-sided die, the numbers 1 through 20 were there, and if I wanted to know the probability of getting an even number, the outcomes there were either the number was even or odd. Now, I could also look at the number of ways that I could get a multiple of 5 for an outcome, and then the outcomes would be that I have a 5 or I don't have a 5. But at any rate, the number of outcomes that you can have from an experiment is called the sample space, and that's what N of U represents. All right, now let's look at a specific example. I'm telling you that a 6-sided or a standard die is rolled, and I'm asking what is the probability that the number thrown is greater than 2. Well, you always have to understand your sample space with any experiment. We're rolling a die, and we're rolling that die one time, and it happens to be a 6-sided die. So the sample space would include the numbers 1 through 6. And that means that there are 6 elements in the sample space, right? And now we got to figure out what the probability that the number thrown is greater than 2. Well, that's the outcome that we're looking for. And we need to determine how many ways can that outcome occur. Well, there are 4 numbers in our sample space that are greater than 2. So the probability that when you throw a 6-sided die that the outcome is greater than 2 would be equal to 4 out of 6, because 4 of the 6 numbers were greater than 2, and there were 6 numbers in total. And you want to simplify probabilities most of the time, and so that's going to give you 2/3. What if I wanted to know what the probability of getting a number that's not a factor of 12 would be? Well, now what we need to do is think about how many different numbers are in our outcome. From the numbers 1 through 6, which are not factors of 12? Well, 1, 2, 3, and 4, and 6 are all factors of 12. Only one digit from 1 through 6 is not a factor of 12, and that's 5. And so the probability of rolling a number that's not a factor of 12 is 1 out of 6, because only one of the 6 possible outcomes was not a factor of 12. There's theoretical probability. Now, this also encompasses things like if you have a 4-color spinner with the colors red, green, yellow, and blue, that you can get a red, green, yellow, or blue 1/4 of the time. Or if you flip a standard coin or fair coin, that you can get heads 50% of the time and you can get tails 50% of the time. That's all theoretical. There's also what's called experimental probability that you need to understand. Now, I've got a lot of words on the screen. You can copy this down eventually, but listen to this for the moment. An experimental probability is based on you running an experiment and seeing how many times an outcome occurs. Now, it's possible that you flip a coin 100 times, and 40 times you get a heads and 60 times you get a tails. So the probability experimentally of getting a heads there would be 40%. All right, so experimental probability is based on you running a number of trials for an experiment and how many times did a certain outcome occur within that number of trials. For an example, we're going to say that 35% of the students in an international school receive a 5 or better on their IB mathematics exam. And I first want us to find the probability that a student scores less than 5. All right. Now, we don't know how many students are in the school in this part. You see already for part B that we will know that, but let's pretend we don't. If we want to find the probability the student scores less than a 5, we need to look back at what is the probability that they will score at least a 5. And 35% of the students will score a 5 or better. That means the remaining 65% will score less than a 5. So you could write your answer as 65% Or you could write that as 65 over 100, which is equal to 13 over 20 if you simplify the fraction. All right, that's an experimental probability. Doesn't always match up with the theoretical probability. The theoretical probability is if you were to run an experiment an infinite number of times, what percentage of the time would you expect a certain outcome? All right, let's suppose that in this experimental probability question that the school in question has 800 students, and I want to find the number of students receiving a 5 or better. Well, 35% of the students scored a 5 or better. So if I want to find out of 800 how many students scored 5 or better, I would have to multiply the probability of getting a 5 or better by how many students there were. Let me write that out. Now, each student out of this population of 800 would be considered a trial, so that each individual student receives either a 5 or better or less than a 5. Those are the possible outcomes that students can receive. And if I want to find the probability that a student has greater than or equal to 5, I've got to find out, well, you know what? I'm writing this incorrectly. If I wanted to find the numbers of 5s, 6s, and 7s that the school would have out of its population of 800 students, I would first take the probability that they get greater than or equal to 5, at least a 5, and multiply by how many trials there are, or in this case, how many students there are. Now, we already know that the probability of a student receiving at least a 5 is 35%, and we're going to multiply that by the number of trials in our experiment, which is 800 because there's 800 students. So that'll be 0.35 times 800. And that's 800 students. All right. Now, the only kind of probability that we haven't discussed here is what's called subjective probability, and that would be the probability that, say, the Lakers are going to beat the Celtics on any given night, and there's lots of things that go into subjective probability. It's not something that we really need to discuss in depth within our IB chapter. All right, so you need to know theoretical probability and experimental probability and how you calculate each one of those things. Thanks for watching, guys. I will see you in the next video. Later.